Hi everyone, welcome back to the channel. In today's video, we are going to break down one of the most important challenges in distributed system design: how to handle data consistency across microservices. And we will explain it visually using a diagram that shows the two main patterns used in real world systems. When you're working with microservices, keeping data consistent is not as simple as it is in a monolith. Each service owns its own data, often has its own database, and might be deployed and scaled independently. That's why we need clear strategies depending on how critical the data is and what trade offs we are willing to make. For operations that require strong consistency, like financial transactions, inventory detection, or order confirmations, we use something called the saga pattern with a central orchestrator. Here's how it works. A service initiates the request, and the saga orchestrator coordinates this sequence of steps. It calls each participating microservice in order, like payment service, then inventory, and then order. If one step fails, it triggers compensating transactions, like refunding a payment or releasing stock to roll back the changes. Tools like temporal, Comodo, or custom orchestrators are commonly used to manage these long running workflows while ensuring data consistency. And of course, observability is critical here. We use tracing, logging, and metrics to track every step. Now, to scenarios where real time accuracy isn't critical, such as logging analytics, updating dashboards, or sending notifications, we go for event driven choreography. Here's how that looks. Each microservice publishes and subscribes to events using a message broker like Kafka. For example, the order service emits an order placed event, the payment service listens and processes it, then emits a payment confirmed event, and so on with inventory and notification services. There is no central coordinator. Each service reacts to the events it cares about. Event driven systems are powerful, but they also require some discipline. Idempotency. Consumers must be able to handle the same event more than once without side effects. Schema versioning. We use tools like Apache Avro, Protobuf, and Schema Registry to make sure changes in event structures don't break consumers. Change data capture. For syncing data from legacy databases, we use tools like DBZM. Also, services can respond to real-time changes without polling. Observability. With open telemetry, tracing, and centralized logging, we can catch issues early and debug cross-service problems quickly. To summarize, use Saga orchestration when consistency is critical and you need full control over the transaction flow. Use event driven choreography when you're optimizing for scalability, flexibility, and eventual consistency. Both patterns have their place. The key is to know when and why to use each. If you found this video helpful, give it a like and don't forget to subscribe for more deep dives into system design and architecture.